Pooh, it's great to have you here. The stage is yours.
Yeah, thank you. Thank you for inviting me to give the talk. So can I share my screen?
Yes, you should be able to share.
Okay, can you see it?
Just fine, yes.
Okay,
Yeah.
hi everyone. It's a pleasure to meet you or online. And my name is Pooh, and I'm a PhD student at New York University, working on NLP. And today I'm going to talk about transfer learning and NLP tools and tips. So if you have questions during the talk, feel free to unmute yourself and interrupt me. I might not see the chat. So yeah. Uh, all right, let's begin the talk. So in this talk, I'm going to briefly cover what transfer learning is and how it is used in NLP. And I'm going to give you some tips on how to maximize the chance of success in transfer learning projects. And then I'm going to share a couple open source tools and library used in NLP these days. And I also would like to give a shout out to my friends Jason and Yada for helping me with the slides and giving me tips. So before we talk about transfer learning, let's talk about supervised learning first. So in supervised learning, we have a label task data for a task, and then we train a model using this label data, and then we only test this model on this particular task. So the task can be, in terms of NLP, the task can be something like sentiment analysis or question answering and so on, machine translation, etc. So we know that in deep learning, supervised learning tasks, we actually need a large amount of label data to train the model and to make it perform well. But we might not always have this large amount of label data because data can be limited for example, for low resource languages or for very specialized domains such as our medical domain, or even for like English everyday language tasks, we might not have enough data for tasks like semantic parsing or dependency parsing because we need expert linguist annotation for those kind of tasks. So data can be limited. So what can we do when we don't have enough data? So we can use transfer learning to get like some sort of performance improvement on those kind of tasks. So what is transfer learning? Transfer learning is a way to share knowledge across languages or domain or related tasks. And since we are sharing the knowledge from other tasks, less training data is required. And since we are not training the model from scratch, it saves time and computational resources. So it is like beneficial to use transfer learning. Also, transfer learning has led to important improvements in NLP these days, and it is really hot and popular in NLP right now. So why use transfer learning in NLP? So language share common linguistic structure and grammatical information and so on. So it is like beneficial to use NLP, transfer learning in NLP. So for example, this is the screenshot of Superglue benchmark, which is for evaluating the general linguistic understanding ability of neural network models. And you can see that this benchmark is actually dominated by transfer learning models and methods. For example, like we have like BERT and all the variants of like transfer learning methods. And you can also see that there are two models currently, which has already surpassed the human baseline in this benchmark. So yeah, these models are really performing very well in NLP. So there are many different transfer learning methods, but in this talk, I'm only going to focus on sequential transfer learning methods, and this method is also currently widely used in NLP these days. So what is sequential transfer learning, especially in NLP context? So as the name suggests, we are going to train the model in a sequential way. So, and do the transfer in a sequential way. For example, we train a model on a task, and then we use this pre-trained model to train another task. So we are going to transfer the knowledge from the previous task to train on the to get better performance on the target task. So first, let's talk about the pre-training. So usually in pre-training, we train a model on data-rich source task. Technically, it can be any source task. For example, there are models that use machine translation as the source task, and there are models that use natural language inference as the source task. But in recent days, many high-performing models mainly use language modeling as the source objective. So what is language modeling? Language modeling is the task of predicting the probability of a sentence or a sequence of words. For example, given the token or words h1 to ht, we are going to train the model to predict the next word ht plus 1. So p of ht plus 1 given h1 to ht is a language modeling objective. So how can we use this? So we can use this kind of a probability information to determine whether the probability of apple given I8 is greater than probability of water given I8, and so on. So this is like one of the things we can do with language modeling information. And the good thing about language modeling is that since we are predicting the probability of the words or sentences in the corpus, we don't really need label data, unlike machine translation, which need parallel data, or natural language inference, which need the classification label data to train. So it is really useful since we don't need the label data. We can just train it on any test corpus. So this is the reason it is widely used. And like I said, many recent high performance models mainly use variants of language modeling in their pre-training objective. For example, BERT model from Google use a mass language modeling objective and next sentence prediction objective. So these are like a few different variants of language modeling. So the first one is, for example, just normal previous language modeling, where they give you a part of a sentence as input, and then ask the model to predict the rest of the sentence. So for mass language modeling, we randomly mask out some words in the sentence, and then ask the model to either predict the entire original sentence or only predict the mask tokens in the sentence. And so on, like shuffling, where we give you the model a shuffle sentence, and then ask the model to recover the original sentence. So there are like different variants of language modeling objective. So now we know how to do the pre-training step in the sequential transfer learning. The next step is to fine-tune this pre-trained model on the target task that we want to use. So how do we do the fine-tuning? So in fine-tuning stage, we use the pre-trained model. Pre-trained model can be something like word embedding. So we're going to use word embedding in a model, and then use it to fine-tune on the target task. Or if we, in the context of language models, we need to add a task-specific layer on top of the language model, and then train the entire model on the task. So for example, if we want to do question answering, we need to add a layer or a few layers for question answering on top of the pre-trained language model, and then train the entire model on the question answering task. So there are a few things we need to consider when we do that. So first, we need to consider which parameters we want to fine-tune. So do we want to fine-tune the entire language model, or do we only want to fine-tune some layers? Because the research has suggested that maybe the lower layers are better for syntax, and the upper layers are better for general information or semantic information. So what kind of information do we want to fine-tune? Or do we want to fine-tune, do something called unfreezing, which is like the initial stage of the training, only fine-tune the last layer and freeze the other layer. And then as the training continue, gradually unfreeze the lower layer one by one, and so on. So this seems to improve the stability of the training. Do we want to do that? And also it has been shown that the learning rate and the number of training epoch actually matter in language modeling. So we need to carefully consider and choose those hyperparameters. So these are a few considerations that we need to do during the fine tuning. So now we know how to kind of do sequential transfer learning in NLP? Can we get a little bit more performance in an easy way? So yes, we can. So this is called intermediate training, or like a supplementary training called STIL. So what they do is instead of just directly fine-tuning the pre-trained model on the target task, we fine-tune it on the intermediate task first to do something like domain interpretation, or to get like more knowledge on some sort of task. So for example, if we want to fine-tune the pre-trained language model on a Stack Overflow question answering dataset, maybe we can actually do language modeling on the computer science test data first to do to adapt the language model to computer science data, and then fine-tune it on the Stack Overflow data. So this gave like some sort of domain interpretation style improvement and like gains in the performance. So, and also if we want to do like some general question answering, maybe we can fine tune it on a related task that is similar to question answering, such as common sense reasoning, and then fine tune it on the question answering. So this actually gives some sort of performance gain than just directly fine tune it on the question answering data set. So this is called intermediate training. So also we can do something like zero-shot cross-lingual transfer during the sequential transfer learning. For example, if we have a multilingual models, for example, multilingual BERT or XLMR, we can fine-tune this multilingual model on an English task. So for example, if we want to do sentiment analysis, we can fine-tune this multilingual model on the English sentiment classification, and we can directly evaluate this fine-tuned model on other languages. For example, we can just directly use this to evaluate the performance on German sentiment classification dataset. So this seems to do pretty well, but not the state of the art, or not very like well yet. So people are still doing research on how to do this better. And we also found in our paper that using English intermediate tasks actually gave performance gains in the cross-lingual target tasks. So for example, if we want to do German sentiment classification, we can actually fine-tune the multilingual model on an English intermediate task, for example, English natural language inference intermediate task, and then we fine-tune this model on the English target task. So for example, English sentiment classification task, and then we evaluate on the German sentiment classification task. So this actually gave a little bit of performance gain than the previous zero-shot model. So another thing I would like to talk about is multitask learning. So in multitask learning, we train 2 or more tasks at the same time using a shared encoder. So we will have like a pre-trained language model as the shared encoder, and then we attach like a few different test heads to the pre-trained model, and then we train all those tasks at the same time together. So there are a few considerations we need to do. So first is like we need to consider which kind of parameters to share across the task. So because we might not need to share all layers like for different tasks. And then some of the tasks in the multitask learning might have like a lot of training data, but some of the tasks might only have like very small amount of data. So if we just train them equally, the task with a large amount of training data is going to overwhelm the task with a small amount of training data. So how do we balance the task with different sizes? So we need to consider this, like how to do this in the multitask training. So next, I'm going to share a few useful tips on transfer learning in NLP. So the first one is you might be wondering, like, how do we pick the task for transfer and multitask learning? Because if we pick the wrong task, the negative transfer can happen. So what is negative transfer? Negative transfer is when we do the transfer learning, instead of getting performance improvement, the performance of the model actually goes down. So this is a bad case, right? So we need to be very careful about how to pick the task. So typically people pick the task based on similarity of the domain. So for example, if our target task is in medical domain, maybe we want to pick the medical text corpus for intermediate training. Or if people also pick the task in terms of task type. For example, if we want to do question answering, maybe we want to pick a similar task as the intermediate task. Or people also use vocabulary overlap to pick the task. So maybe like we need to figure out like how many words are overlapping between the source and the target task, and then pick that task as the source task. And there are like some recent method called task embedding, which is actually learning the embedding for each task, and then choose the source task based on the embedding similarity between the source task and the target task. So this is still kind of an open-ended research question. So people are still trying to figure out the best way to choose like the source task for the transfer learning or the best combination task for the multi-task learning. And we are also still trying to work on this question in our lab. So the next tip is my language model fine-tuning can be very sensitive to optimization parameters, as I kind of mentioned in the considerations. So it is actually very sensitive to learning rate and the number of epochs. So the recommendation is to train longer, especially for a very small data set. Training longer seems to give the stability to the performance of the language model, and use a very small learning rate if you can. So this is like these two papers analyzed this and then recommended these two facts. And another tip is to be mindful about catastrophic forgetting. So catastrophic forgetting is forgetting of the previously learned information when you try to learn new information. So for example, let's say we have a multilingual model and we train the multilingual model on English tasks to do the zero-shot transfer. So when we do this English training, the model might forget previously learned information about other languages. So this can happen, and we need to prevent like this by adding some regularization methods to minimize the catastrophic forgetting. So in multitask learning, like I said, if we can have like tasks with different sizes in our multitask learning training, so how do we balance those tasks? So people usually balance the tasks based on dataset size. So like maybe trying, and some other people also use temperature-based sampling. So what they do is they first balance the task based on dataset size. So, but try to use some kind of temperature to upsample the task with smaller data and downsample the task with a very large amount of data, so that all the data set gets the attention that they need. And then there are also research going on to automatically learn the task ratio or the task weight during the multitask learning using meta learning. So this is also like an active area of research. So people usually use like dataset size and try to find the temperature based on hyperparameter tuning methods. But there is still like research going on about how to do like this automatically. Another thing, and I think this is very important, is to be mindful about social biases in pre-trained language model and the data set that you're using, especially if you like want to use that in production. So for example, this is the visualization of the gender bias by robot.large model, which is a very popular model from Facebook AI research, and fine-tuned on the squad question answering dataset, which is also a popular question answering dataset. So you can see that the model actually associate female with words like babysitter, cashier, clerk, cook, and dancer, while it associate male with banker, bodyguard, captain, butcher, and so on. So this kind of social biases about gender or religion or nationality and so on exists in the language model. So please be very mindful about those biases when especially if you want to use that in production. Yeah. So another tip we would like to share, this is mainly for implementation. So a lot of things stay very hand wavy, and you might need to run a lot of experiments with different data sets or different combination of tasks and hyperparameter before finding one that works for your task. So it is very important to use a modular plug and play code for different components of the transfer learning. So for example, like maybe add some components for testing and some component for training and so on, because so that if we want to change one part, we can change it without affecting the other parts of the code. And we need to save like model configs and checkpoint at regular interval, so that if like something happened, we don't have to start from the scratch again. We can just start from like one of the checkpoints. And and we can produce parameter and performance logs at every step, so that it would be easy to debug, and it would be easy to check like which stage the performance is going wrong, so that we can just restart from that stage instead of like doing everything from scratch again, which can be very expensive. And we should automate like the experiments as much as we can. So actually, I'm going to introduce a library called Giant, which actually handle all these steps later. So yeah, this is like kind of a promotion to our model. So first, now I'm going to introduce some open source tools. So I think everyone who works in NLP kind of know what Hugging Face is. So this is a very good library. And so the first one is, how do we find the data set easily? So Hugging Face has like a lot of data set, and those data sets are in like many different languages. For example, you can just go to huggingface.co.datasets, and then you can like search for the kind of data set you want. And you can also filter by language or the size of the data set. And so it is very useful. So after finding the data set, for example, this is like acronym identification data set, you can just directly use like from data set, import log data set, and then directly use acronym identification data set. So you don't have to like do, so this is going to download the data set automatically for you and load it in the data set variable for you. So you don't have to handle like data loading steps and so on in your code. And it's very useful. And they have like data set, many different data set in many different languages. So this is very useful. The next step is where do we find the pre-trained model? So Hugging Face also hosts very popular pre-trained models from research lab, and also they also accept like the submission from open source developer. So we can also submit our own model to Hugging Face dataset. So, and we can also search for models. So for example, if we want to search for a model that is already trained on sentiment, we can actually just go and search in sentiment, and it will give you a list of models that are actually already fine-tuned on sentiment. We can even see there's like a German sentiment BERT. So yeah, this is really useful. And next, how do we set up transfer learning experiments? So we can actually use Hugging Face to do transfer learning experiments also, but most of the code needs to be written on our own. So in our lab, we built a library called Giant, which is a PyTorch library for natural language understanding, and it focuses on multitask learning and transfer learning research. It is mainly focusing on research, so it contains a lot of like popular data sets and tasks for tasks people in NLP research usually use. But you can also add your own tasks and your own data if you want to use it in production. So this library is very simple, flexible, and it has like very flexible training pipeline. And it is built on the Hugging Face transformers and datasets. So you can seamlessly use Hugging Face models and dataset in our Giant library. And this library is designed to be modular, so that you can just like change any part in the library on your own if you need to modify. And you can just do plug and play any part of the workflow. And it is also very easy to add your own tasks and dataset. And we also have like we also keep expanding our library and like the tasks in our library. So if you're interested, you can go and check out giant.info. So I am going to talk a little bit more about Giant. So Giant contains 3 components. It has like task, model, and runner. So first, tasks. So the tasks, in terms of tasks, Giant support 50 plus tasks out of the box. Most of them are very popular NLP tasks used in research. And we also have some kind of like NLP probing tasks, which is like the task for those are the tasks for like probing the model, whether the model know some kind of linguistic information or not. For example, if we have like any probing task, this is going to like probe the model whether the model know any information, name entity information or not. And like I said, it's easy to add a new task if you want to use it for your own custom data set. And if you are a researcher who wants to use it to submit your model's performance to like natural language understanding evaluation benchmark like GLUE, which is the general language understanding evaluation benchmark, and Super GLUE, which is like a harder version of GLUE with low resource data set, or HStream, which is a multilingual or cross-lingual language evaluation data set. So if you want to do like submissions to those kind of popular benchmark, you can directly do that in using Giant. So this is like convenient if you are a researcher, not so much if you're a developer. So we also have a task downloader. So this is like a downloader that is going to download the task or data from the Hugging Face, and then you can get started right away if you want to like use Hugging Face dataset. And we also include necessary preprocessing code for the necessary preprocessing steps. So because the preprocessing such as tokenization should be done for like differently for different models. For example, BERT has its own BERT tokenizer, Roboto model has its own Roboto tokenizer. So we handle all those things in our library. So it is really useful for a custom data set. You just need to choose like how to get your data, and then the rest is going to be handled by Giant. So the second stage in Giant is models. So a Giant model consists of a text encoder, which is the BERT model or Roboto model or other pre-trained language model. And we have like one or more test-specific dataset heads. So like I kind of mentioned before, if we want to use a pre-trained language model, we need to build our own test-specific heads. So Giant already have like a lot of heads implemented in our library. So we can just choose like any head to go together with the encoder. So these are the kind of the supported test head in our library. So currently we can do classification, regression, multiple choice, tagging, multi-level span comparison, question answering, mass language modeling, and span prediction tasks, such as like squad question answering and so on. We cannot currently do generation yet. So you cannot use Giant for generating the data or machine translation, but we might add this support later on. And we also support most of the popular pre-trained language models, such as BERT Roboto and multilingual model XLMR, LBERT, and BERT, and so on. And this is also like expanding. And the last step is called runner. So runner is the part where we are going to train the model. So the training loop and how to balance the data and so on, and like logging of the training step and saving the models and so on are handled by runner. So runner handle training and evaluation control flow, and it has native support for multitask training. So it also let you like choose different types of sampling for multitask training, and the score aggregation strategies for how to maximize the performance for different tasks. So in multitask training, you might want to maximize the performance for all the tasks, or maybe you might want to maximize the performance for one particular task, and you might not really care about the performance of other tasks in training. So we let you do that by like letting you choose the score aggregation strategies. And we also support things like early stopping of the training and saving and loading of a checkpoint, and things like gradient accumulation and multi-GPU parallel training and so on. So this is the pipeline for Giant. So first we need to download the data. Usually this is like done using the Hugging Face library, and we have the code that handles that. And then we need to download the model that we want to use. Then after that, we need to tokenize and cache the data using the tokenizer from the model. And then we have to write a config for training the model, such as like how many training steps do we want to use? What is the batch size? If we are using multitask training, how do we want to sample the task? And other specific training related details should be written in the run config. And then we can just like run the experiments, and it will like handle the training and the rest for you. So it has two different API. The simple API, which does every stage in the pipeline in a single call. So it downloads the model, pre-process, and do the training on its own by just like one line. And this is like the starting point for everyone. So we can just run this command. For example, we can give the training a name symbol, and then we can specify the experiment directory. And then we can specify the data directory, and then we can specify the model that we want to use. So in this case, it's BERT based, and we can specify the task. So MRBC is kind of like reading comprehension task, and RTE is natural language inference classification task. So this is going to be a multitask training since we specify two tasks, and we can specify things like batch size and training epoch, and also we can specify learning rate and so on. If we don't specify it, there's some default learning rate already set for doing that in the library. So the second, this is the simple, that was the simple API. The second case is the main API. So in main API, we have command for each step in the pipeline. So you can just like modify any step on your own. And then, so it's good for customizability. So for example, like for download data, it will have like the code for downloading the data. And if you want to use your own data, you can just modify this step. And and any point in the pipeline, you can just directly go and modify that step, like without affecting the other parts of the pipeline. So, and the question is like, how do we, if you want to add on your own task, how do we do that? So we also have like very extensive documentation on our GitHub. So you can like read this and then try to add your own tasks and models. And you can also contact us or submit an issue on our GitHub if you need help doing that. So is there like any question so far until now?
If you have a question for Pooh, you can unmute yourself and ask directly, or also post a question on the chat and we're going to read it.
Okay, my question, I had one question.
Yeah.
You mentioned in the beginning that this language model introduced this gender bias. So this gender bias basically comes from your training data, and as long as you're training with this data, you cannot do anything with it. So how would you mitigate it?
Yeah, so all these pre-trained language models are usually trained on publicly available data sets such as Wikipedia or Reddit data, which is like really bad in terms of like social bias. So there are papers which propose like methods for like reducing the bias in bias of those models. So like we can use like debiasing methods and so on. But I think still the bias is going to exist. So especially if your data set has like is biased. For example, if you're doing like resume scanning resume scanning model, so the data set that you train might already have like some gender bias. So you have to like maybe build the data or like filter the data on your own to be like to balance the gender ratios in the data set itself, and then also like use some kind of regularization methods to mitigate the bias of the model itself.
There is another question from the chat. Have you tried genetic programming for NLP? And I would add, is genetic programming relevant in the NLP field?
I have not tried it, and yeah, I don't really know a lot about that topic to comment. Sorry about that. Yeah. But if there are people who know, like, feel free to chime in.
Any more questions? There's a follow-up question about gender bias coming.
Hello, this is Upayan.
Yeah.
Thank you for the nice talk. So one question that I was curious about this handling this gender bias issue is that do you know about the existence of data sets which identify whether some sentences are biased, gender biased or not? In that case, maybe we could run a model, retrain a model on that data set, and then apply it to identifying the biased sentences in the current data set?
I don't think I have seen the data set that actually find the bias in the data set itself. I have mostly only seen the data set that specify the biases in the model that is already trained. So, but you can use those data sets. For example, you can train a model on your data set, and then you can use that model and then make the model to predict predict the gender bias sentences, and then maybe the gender bias data set would tell you that your model is actually biased. So maybe that's the only way I currently know right now, and I don't think there are like methods that directly specify a sentence that is biased, because it's really hard to tell. So for example, this encoder data set is a way to identify the bias in the, sorry for going back. Maybe. So this is the model, the data set that I show in the demo. So it contains like sentences like this. For example, we have like an example paragraph about gender. So the person over the screen is Angela, and sitting by the side is Patrick. So who was an entrepreneur? So the model should be like a bias model is going to answer that Patrick is an entrepreneur. So there's like no information about entrepreneur in the sentence at all. But unbiased model should say like 50-50 probability that both Angela and Patrick can be entrepreneur. So the bias model says Patrick is the entrepreneur, and so on. And they have like racial bias. For example, Asian woman was taking classes and with a Caucasian woman who is a bad driver. And the bias model is going to answer that Asian woman is a bad driver. So we can use this kind of data set to test whether a model is biased or not.
Okay, so it is more difficult to identify the intrinsic biases. Thank you.
Yeah.
Understood. Yeah.
Chris is asking, have you come across any data sets that labels imperative sentences that require a task?
Sentences that require. Can you give me an example of that? So So like, any data set that labels imperative are.
Oh, examples coming, like, please send me the report, or can you take out the trash? Thanks for clarifying.
So it is like, so for example, for those sentences, we need to identify the task or the intention. I think there are some intent classification dataset exists. Yeah. So yeah, I don't really know anything right now out of the top of my head, but they definitely exist, especially in the conversational model field, I think. Yeah, sorry about it.
Here's another question from Jacqueline. If you have multilingual pre-trained data, why would you train your data on an English data set if you want to apply your model to German data? Wouldn't that rather cause interference?
Yeah, so if you already have a large German training data, it is best to just directly train on that German training data. I think the cost for cross-lingual transfer learning is mainly for low resource languages where we don't have like enough data for to train the model. For example, my native language, Burmese, don't really have any good data set. So, and they are not publicly available even if they have them. So we need to do this kind of cross-lingual manipulation to like do well on some tasks. Yeah, but it is the best to just directly train on the target language data if you have the data. And also cross-lingual training or cross-lingual intermediate training can give you some performance gains if the source language is very similar to the target language. For example, Spanish and English are kind of similar in terms of some subwords vocabulary. So it can give you performance gain, but English might not be very useful for like languages in other language families, such as Tibetan languages or Burmese languages. So how much time do I left for a demo or?
Take your time for the demo. Are there any urgent questions for Pooh before she shows us the demo? No? So I think you're good to go with the demo.
Okay. So this is the link for the demo. I will also paste it in the chat in case you want to do it on your own. So this is just like showing how to train a multitask model in Giant using some popular datasets such as RTE, which is a classification task for natural language inference, and STSB, which is a Stanford sentiment analysis dataset, and Common Sense QA, a QA task for common sense reasoning. So first, we need to clone the library and install the requirements. So I already kind of pre-ran this before coming here. And then the first stage in the pipeline is to download the dataset. So Hugging Face, we are going to download the dataset from Hugging Face and save it in our output path. So we specify the task that we want to download, RTE, STSB, and Common Sense QA. So if you have implemented your own task in our library, you can also specify the name of the task, your own task. And then after that, we are going to import some libraries and yeah, functions that we're going to use from Giant. And then we need to download the models. So if you have your own model, you can use your own model. Otherwise, we are going to export the model from Hugging Face. So currently, this is using a Roboto-based model from Hugging Face. And then we specify the path to save the model. So yeah. And then the next step in the pipeline is to do tokenization and catching of the model so that we can easily use it during the training. So we are going to identify the tokenizer that we want to use, which is the robot-based tokenizer, since our model is robot-based. And then we are going to identify the path for each data set. So the configs are going to be there automatically downloaded when we install Giant. And then we are going to tokenize each task. So this is going to be handled, the tokenization is going to be handled by Giant also. And then we are going to cache each data and then print it out the data. So this is like how the data look like after converting the words into indices. And this is like the original sentence in that is already tokenized. For example, like no weapons of mass destruction. And this, we have this kind of weird G symbol because the tokenizer is using BPE tokenization, which add those kind of tokens in the during the tokenization stage. But we don't have to worry about that. So this is just like printing out some kind of data from different data sets. So this is like from RTE and STSB and Common Sense QA. So after that, we can start writing the RAN configuration. So we are going to use simple multitask configurator API. So we specify the task that we want to use in the training, and we want the task that we want to use in validation. So for example, we might want to maximize the performance of all tasks. So we might want to use all the tasks in the validation, or maybe we might only want to use like RTE because we only care about RTE performance. So maybe we might want to only validate based on RTE performance. And we can also specify the training training batch size and evaluation batch size, and how many epoch do we want to train, and how many GPUs do we want to use. If you have more than one GPU, you can specify that, and the Giant is going to handle the parallel training for you. And during the multitask learning stage, we can also like specify how do we want to sample the data. So proportional sampling is going to sample the data based on the data set size proportion, but there are other sampling methods such as temperature sampling and other advanced sampling methods that are in Giant. So you can take a look at the library for more information. So, and we have like other test configuration that are like set by default. Yeah. And we are using aggregation method equal metric aggregator. So we want to focus on all the tasks equally instead of like just one task or some tasks. And then we can just like use this rank configuration that we wrote just now, and then use it to like ran. So we can specify the learning rate that we want to use, how frequently do we want to do the evaluation, and do we want to train, or do we want to validate, or do we want to do only one of them, and so on. And if we have like some pre-trained model, do we want to override the pre-trained model, or do we want to just pick up from the previously trained model and continue training that? So we can specify all these in our rank configuration, and then we can just do like a ran loop and then run argument, and then this is going to start training the model. And yeah, so this is like first it print out all the model config so that we can remember then for debugging. And so this is just logging, and after that it is going to start training the model and evaluate every step, and then at the end is going to produce the performance for each of the tasks. So this is really useful if you're doing like mainstream NLP research, but also in production if it is like easy to add your own tasks. So it can be useful, I guess. So any question regarding this?
Any urgent questions? Because we should be going to a 10 minutes break. But first of all, thank you so much, Puma. Let's have a round of applause. Thank you for the great talk.
Yeah, thank you everyone for attending and discussion. Yeah.
Thank you.
Yeah. And thank you also for inviting me.
I don't see any urgent
Thank you.
question. Let's go to the 10 minutes break and then meet again for the second talk of the evening.
Anybody who doesn't need a break is happy, welcome to network if you do like that. Gianluca, do you want to start? Or everyone of us says one name, then we're equally doing some introduction. So because it's just a few words.
Okay, so we'll have our second talk now, which is more about applying NLP in production. And our speakers today, Sebastian Nichtern from Ginkgo Analytics and Adrian Baetu from Hapag-Lloyd will be talking about NLP-based customer service automation at scale. So I think Kai, I've already dealt with most of the introduction now, and we can hand it off to our speakers.
Yeah, thank you. Let me share the screen. Good. Yes, thank you, and a warm welcome to you, to the community, and thank you very much for having us here. I'm really happy. Maybe not everybody will know what Hapag-Lloyd actually does. But if you look in the background of this image, you see that we have a lot of containers and we have quite a lot of big vessels. And we basically move cargo over the ocean, door to door, worldwide. We are the 5th biggest carrier in the world. And nowadays, even the most profitable one. So, as you can imagine, there's quite a lot of communication going on between us and the customers, legal entities, service providers, and also we provide a lot of digital products to have optimized access to our services. A lot of communication arrives us as email. So 2019, we started a couple of proof of concepts in the area of NLP. And today we want to show you what we achieved and how we got there. My name is Adrian Baetu. I'm since 8 years with Hapag-Lloyd. I have quite a rich history in the area of system engineering. And my love to AI actually started during my studies when I had the chance to play around with my first backpropagation algorithms. So you can imagine how good it feels nowadays, because I didn't lost my love till now, and now I'm allowed to build up the first AI team at Hapag-Lloyd. But let me introduce now my partner on this journey, Sebastian Nichtern.
Yeah, hey guys, exciting to be here. Welcome and hello also from my side. Yeah, my name is Sebastian Nichtern. I'm a senior data scientist working for Ginkgo Analytics. We are a small consulting firm providing data science as a service to a lot of the big clients in Germany, Deutsche Bahn, Lufthansa, Merck, and of course Hapag-Lloyd. I will try to introduce myself really quickly, but I think this might be really valuable, especially for the people here that are just getting into the field of data science. So yeah, I actually studied process engineering. I finished my master in 2017. I then decided to go with my passion, which was more of a side project back then, which was machine learning and data science. I went to University of Hamburg for 1 year, took all the classes there that are related to that topic. Then I participated in a lot of hackathons and Kaggle challenges, which I can highly recommend in the beginning, especially because there are really skilled data scientists there in these online communities, and a lot of code where you can learn really hands-on how to solve tasks. And then in 2019, I joined Ginkgo Analytics, worked with a few clients, and then started working also for Hapag-Lloyd. Actually, I met Adrian over a meetup, which is kind of nice, and now we are talking together at one. Just realized that. So yeah, Meetups are also really good platform, especially when you're in person, of course. Yeah, we prototyped 6 NLP use cases, and in 2020, we actually deployed 2 of those, which are currently live and automating over 11 million requests every year. Thank you for now, and for now, back to you, Adrian.
Thank you, Sebastian. So quality is actually a promise that Hapag-Lloyd gives to our customers. We have recently deployed a dashboard that is publicly available, so our customers can see how we are striving to accomplish these promises. And the solution that we are going to present to you today is one building block that allows us to improve and achieve these promises. I will give you a short introduction into the business case itself. Sebastian will go deep dive with you into the technical solution. And at the end, we'll talk about some success factors that made these results possible. So what we are going to talk about today is the bill of lading. Most probably not many people know what a bill of lading is. It is one of the most important documents in the shipping industry. It's a legal binding document, and it basically contains all information required for transporting the cargo. So if you look to the left down, the story starts with the customer sending us instructions with when he wants his cargo to be transported, where it starts, where it should go to, so destination, what will be in it, how much, who pays what. And we are compiling this to a first draft of this bill of lading, return it to the customer. The customer might have some change wishes, and eventually after some forth and back, we will end up with an approval from the customer, so we can release the official bill of lading, and then only then the shipment can start. So can go on the vessel and go towards its destination. Behind the scenes, we have to deal with 40,000 emails per day. They arrive us in parallel. The customers are sending them in parallel to us in various formats, and mostly in unstructured text, like you see below. So we have a team in the middle who has to read the mail, understand and see, is it an initial shipping instruction? Is it a draft correction request? Is it an approval? So they tag it like that and send it to the right expert to provide the answer. We, of course, have the support of our freight information system, but still there are quite some more types of mails that we have. And this process can take between 10 to 2 hours per mail, 40,000 mails per day, 10 minutes to 2 hours. This is not because the people are so slow or because the mails are so big, but it's just due to the volume. So it piles up, and that's why you end up taking a long time for one mail. And this is exactly what we addressed. We introduced an AI that can read and understand the mail to the extent that it can detect the type of the mail, initial shipping instruction, draft correction, and 7 more. So we reduce the time of this process to 3 seconds because the AI can scale if you do it right. So Sebastian will tell us how to do that right?
Yes, exactly. So first of all, I would like to go into a little bit of the requirements to make AI work in production. So first of all, I would recommend always to first have a prototyping phase. So in that phase, you actually get the historical data of your use case. In this scenario, the emails from Hapag-Lloyd together with the labels from a database that are currently filled by humans. And then you also, of course, need an experienced data scientist who then does all the data exploration, cleaning, model design and training. And also a subject matter expert. So in this case, someone from Hapag-Lloyd who actually knows the process really well, and can you explain to you all of the classes and the data that you get. And then on the deployment side, so when the prototyping leads to good results, is successful, then you go and try to deploy your solution. Here you require a digitalized process, so that you just can kind of plug your AI module into an existing structure of the IT, for example, in this case of Hapag-Lloyd. And yes, and what you also need is a deployment environment. So something, for example, a cloud provider like AWS or Google Cloud. They provide you a lot of managed service for model services for model serving. They provide you with functionalities like scalability, availability. They think about security, compliance, governance, monitoring. So all of these topics are really key to big corporations to make everything work really safe and reliably, even at scale. And then what you also need is a deployment team. So usually this is not the deployment on such a cloud provider is not a job of a data scientist, but of a DevOps engineer and maybe a data engineer. There are like different names for these kind of roles currently. And yeah, so we worked actually together with a partner here, and I just wrote all the cleaning and predictive code, and they set up all the cloud infrastructure and services there. Next slide, please. So what have I done as a data scientist in this particular project? So yeah, this is an NLP meetup also. So probably some of you are happy to see that I used a normal bag of words TF-IDF vectorization together with an ensemble of decision trees called a random forest classifier. This is pretty much a baseline model, really basic. Long time before BERT was around, this was state of the art. And it still leads to really, really good results. And it is set up pretty quickly. That's also why I always recommend to first train a baseline model and then go from there with more complex neural net kind of stuff. With this, we reach an accuracy in this particular classification task of over 60%. This accuracy is actually higher, like 79% or something, but we already applied a confidence threshold, which is something I also really recommend doing, so that you only take the predictions of the model that have a certain accuracy, for example, over 60% or something. This is, of course, use case specific. With this, of course, you reduce your total automation rate. So you can see here we have introduced this 40% not classified, but you reduce heavily the amount of incorrect classifications, in this case to only 9%. On the right, you can also see the related confusion matrix. So there are all the classes again and specific accuracies and yeah, how many of the different mails are categorized in incorrect and what sort of incorrect class. And you can also then check, for example, if something important is classified into spam often or something like this, because this would be like a really bad case scenario. Can you click? Yeah, thank you. So then like half a year ago or something, we had some more time in the project. And then we actually implemented something more state-of-the-art, which is BERT. We just had, fortunately, a really long talk about this, so I don't really have to explain a lot. We used the tokenizer from BERT. So here we also try to make use of the just explain transfer learning. So we used a pre-trained BERT model that is trained on large corpora, Wikipedia corpora, multilingual, because also our data set of the mails is multilingual. As you can see here on the right, now our total accuracy increased of around 10%. And so actually the transfer learning seems to work quite well. A really fun and cool side effect was that actually you can see at spam the accuracy decreased in comparison to random forest from about 90% to 80%. So BERT seems to be more cautious about what he predicts into spam, even though he doesn't have any clue about what spam is. But he seems to understand that spam is something which is really diversified. And so it was a positive side effect for us. Of course, you can now interpret it if this is like really a behavior that is led from some sort of intelligence in comparison to a random forest model, or if this is just a random experience. Like one last note here, of course, those models are much more complex to implement. But as our speaker before told you already, there is a really cool library from Hugging Face called Transformers. That is the one we also used. Highly recommend this library, really, really good. Yeah, with this, and the training set was about 4 million emails. It took 2 to 6 days, depending on how many epochs, so how many total runs you go through the data set to train the model. And this is also something you have to consider. So if you have a tough deadline and then your model trains really long, you can only pray that the results also will look really good. Next slide. So here you can see the actual deployment infrastructure on AWS. For those of you who have never heard of AWS, this will be a little bit complex, but we will get to more informative stuff for you guys as well in a minute. So on the left, you can see the customers sending a mail to Hapag-Lloyd. This is then going to the on-prem Exchange, Microsoft Exchange server, and then they send it to the AWS environment over an API gateway, which invokes a Lambda. Then the Lambda stores the result in a database, the metadata and the email as PDF format in S3 bucket, and puts an element into the first queue. Then we have a Fargate instance here called cleaning, which runs Dockerized containers with cleaning code. So this is just picking up the elements from the queue, loading the mail, the PDF mail, and extracting it, transforming it into text, and also performing some cleaning steps like removing stop words, for example, stuff like this. This is really cool because this can parallelize quite well. So if the queue has too many elements, more container instances can spin up, and yeah, just reduce the load there. Click again, yeah. So the cleaning then is writing the clean mail into an S3 bucket again and putting an element into the queue. Then we have another Fargate instance, which is doing then the featureization and the prediction, writing the results into the next queue. And this invokes a Lambda. Click again, yeah. And this Lambda will then also write the result into a database and send this back to the freight information system of Hapag-Lloyd. Next slide. So here on the top, you can again see the architecture. On the bottom left, you see the actual dashboard on AWS CloudWatch. So all of these services that you can see on the top, as you can see, this is a really microservice-focused architecture. So all services report their own metrics to AWS CloudWatch. So you have your own log groups there for each service, which is really comfortable, especially in software, because you always will have some bugs or something will go wrong, and then you can really quickly find where you have to look and fix it really fast. So on the bottom left, as you can see, some metrics that these services report. So here we performed an actual load test. So on the top left, you can see the mails coming into the API service, which is around 200 per minute, sorry. And you can see below that the initial queue, so the cleaning queue in orange, is stacking up. This is because, yeah, exactly, because there are not enough cleaning instances running, because they have to extract a lot of PDFs and stuff. So this takes some time. So then the Fargate instance recognizes, okay, there are a certain amount of elements in the queue, so we have to spin up new instances, and then you can see how the amount of elements in the queue will go down. This is the first drop, and then the instances stop again, and then new elements come in, of course. So it will pile up again, and then a new instances start again, and it will go down again. So this application is really flexibly adjusting with the load that's coming in, which is really nice. And you also only pay, of course, on AWS for the services that you use. So only the instances that are running are producing costs. So you most of the time don't need that many instances, and sometimes you have really high load at certain times of the day, and then new instances will just spin up. On the right, you will see a total execution time, which is around 3,000 milliseconds, so 3 seconds per mail. So through the whole application, it takes 3 seconds to get a prediction back for like thousands of mails. So on the right, you can see the technology stack that we used. I will quickly go over it again. Of course, AWS cloud architecture, self-managed services, scalable, reliable, flexible, secure. By the way, I'm not paid by AWS to say this. It's just experience. And we also work with other cloud providers, so we are not biased in that regard. Google Cloud does the same thing, for example, right? Okay, so you can go with any one of these. Infrastructure as code in Terraform. So the whole infrastructure that you see on the top left is set up actually in code, so you can actually just create a new AWS account and then click kind of build, and then all the services will be set up, all the code will be transformed, will be there, and everything will work. That's in theory. Of course, this will take some wriggling, but we actually deploy to a new account within a few days. So this is quite cool. Yeah, we use, as I said, scalable containers, so you can really good, well, parallelize everything. You have this isolation of microservices, which is really good concept, state-of-the-art practice actually, and you have this high reliability through encapsulation. And CI/CD pipelines, so we have actual cross-account deployments, so we have multiple AWS accounts, and if you introduce a change, you will do this in dev, and then you will just test against it. For example, run the load test again, and the production environment will just run all the time. And then you can just say, okay, everything is fine, and then deploy to QA and test again, and then to production really quickly, really easily. And yeah, this is, yeah, I would highly recommend if you have such a big and complex application to go with something like this. Fully asynchronous, so yeah, this queue concept is also quite nice because it's fail-safe. Even if something breaks, the queues will just stack up and you will not lose anything or any mails. Okay, I think that's it from my side for now, from the solution, and I would give back to Adrian. Thank you.
Thank you, Sebastian. So let's have a look on the results that we achieved with this approach. Yeah, we can bluntly say that we can automate 60% roughly of the incoming mails. And of course, you maybe might say, well, what about the rest of 40%? One thing that you should think is this process has zero automation before. So automating 60% out of 40,000 mails per day is quite a benefit. And the second thing that is maybe not so obvious at the beginning, doing this at accuracy level of 98.7% or error rate of 1.3% is quite an achievement. And this is actually what it makes so challenging to apply AI solutions in a real corporate level environments where you cannot accept error rates of, I don't know, so accuracies of 90% or even 95%, yeah, because the customers will not accept that you just didn't process their shipping instruction. Yeah, so saying this, we have reached quite a high automation rate at really good speeds. So we scale up like nothing, zero downtime when we deploy things. If something goes wrong, no problem. It's very robust. the mails just pile up in the queue, and when the problem is solved, they just are get post-processed. So the business doesn't really have to worry on that. These are the really nice parts of it. And in terms of business value, if you have a look on our status here, end of 2019, we had a promise. This is actually the timely and correct bill of lading is a KPI that is impacted by our solution improvement. And we managed in 80% of the time to deliver our response to the customer within 4 hours, and in 91% of the time within 8 hours. And end of November, after we have deployed the application and it was running since few months, you can see that we achieved already 90% below 4 hours and a bit better below 8 hours. Of course, not all of this is due to our solution. There are a lot of initiatives that are adding up to this quality promise, but we are really proud that we could provide improvement on that. So what about some of the success factors, some of the things that helped to achieve that? One point is you start with a business case, and you have to understand the business case if you want to develop any kind of software. And this is not differently for AI, but there is something about AI, because when you do predictions, you come with a certain accuracy, because you're definitely working with big data, so you don't apply just a few business rules where you can have some checks for 10 possible outcomes, 10 scenarios, and done. And what you should not forget is that whatever your AI is automating, it is producing a result that has to be consumed by a follow-up process. You're not in the wild. The result of your AI is not valuable on its own. It is valuable because it is consumed by a follow-up process. So if you miss the point of having analyzing the follow-up process and identify how critical, and this is what I try to talk here about, how critical errorness, so a non-correct result is. Like, for example, identifying a shipping instruction email as a spam. Well, nobody is there to detect that. The customer will wait forever and will just escalate. So some of the results are more critical. Some of your classes are more critical to the follow-up process than others. A shipping instruction that has been identified as a draft approval comes actually to an expert, and the expert will see, oh, that's not a draft approval, this is a shipping instruction. Done. So less critical than spam. And that's why when you train and design your model and optimize your model, you will definitely knowing this early, you will focus on optimizing accuracy towards the most critical classes you have. Another topic is the key performance indicator, or the measurement of did this AI actually solve the problem of my customer? And how do I measure this? And the problem, the difference between standard business rule-based solutions, where you have a set of business rules, a set of use cases that you have discussed with your customer, and mostly it is relatively easy to set up some metrics and measure them. In the field of AI, you don't have this luxury, and you don't even have the common understanding. So the business is not used to understand, to deal with results that come with a certain confidence threshold and with a certain chance to be correct. Yeah. And then it comes very late that they realize what this means, and they and boil it down to, okay, I have a lot of results automated, but quite a lot, some of them are not correct, so I have to deal with that. So some of the automation that happens is wrong, and the final efficiency gain, so like how much of the workload of the business have we really automated, is lower than the initial measured accuracy of automation rate that you can derive from the accuracy of the model. If it's not totally understandable here, the key message is start very early to discuss and transfer understanding of what the performance key performance indicators are for the solution you're building. Compliance can be surprising because you cannot train a model on synthetic data. I mean, that's a bit incorrect. We know there's an area that's trying to introduce that. But in general, if you want to build a model that will work on real data, you have to train it on real data. Real data in corporate environment mostly has some confidential and PII related information into it. So you cannot just, you can try to download on your corporate laptop, but your laptop will not be able to train a BERT model at scale. So you need to have your experiments, even your initial experiments, you need to have them potentially in a cloud. Well, in a cloud, there you are very near to public. So you first have to have an NDA and a corporate setup in the cloud with all the compliance regulation secured there, and then you can start and even assess a use case with data and even do some experiments. So if you don't have that yet in place in your context, yeah, then start now. Solution acceptance, it's a bit related with the KPI topic. So since the AI does not follow a predefined set of rules, yeah, and your users are normally used to applications and that actually apply a set of 10, 20 business rules and 10, 20 use cases. While an AI is, if you look behind if we take just this decision tree and a random forest approach, and a model has generated actually and covered hundreds of business rules, hundreds of use cases. That's why we have to go for machine learning, because the topic is too complex for standard application development. And that's why the users will have to learn how to the value and to understand the value of result that comes with a confidence level and an accuracy, so with a probability of being right. Starting, if you start in a company where AI solutions are not yet like rolled out and your business users are not yet accustomed to that, then consider that starting early to discuss with them how you want actually to conduct the UAT, how do we want to define what is an acceptable solution for you very early, because you have to transport, at least for the first few projects, this understanding as well. The rollout is also related to that, and I maybe just reduce it to it. In a global international company, you apply, especially in NLP, you apply your model to one pilot area. Normally, you don't apply it immediately to the whole world. So you don't want to spoil it with everybody at once. AI applications are per se more risky than standard applications. And that's why, taking into account that after you have survived the first pilot area where you proved, yes, the application is doing the job, well, maybe it did it very well in USA, in England, in English. And well, let's hope that it's doing as good in China, right? So be prepared that you will have to roll it out step by step for different teams. Different teams will have to accept your solution, will have to learn to accept the solution and assess it. And this will take, for the first project, a bit more time and efforts and costs and budget. That's it from our side. Thank you very much for your attention, and yeah, looking forward to your questions.
Yeah, one last point, just adding it to the presentation sort of, is that we actually, Geek Analytics, are hiring. So if I saw some people like are really interested to go into the field. So we're searching for data scientists, data engineers, and just like ping me on LinkedIn, write me, and we can have a phone call. And yeah, exactly. Maybe you will be one of our data scientists and do some exciting projects. Yeah, thank you. We welcome your questions.
Can I jump in for a question, please?
Sure.
Two question. What is the next automation on your plate? Just curiosity. And another question: did you consider like having a human see the result of the model, even when the model is not sure, just to present the user, this is what the model is thinking, click on the right choice if you have an opinion?
So normally, yes. Unfortunately, not playing on the green field. I'm answering your second question first. Not playing on this second field. It's this would require a change of very standard screens that we have, and change of workflow. This normally ends up to have to train people. So we didn't went this step. And we also learned now, we did quite an extensive manual review over time. So the business teams have got from us the elements that we have indexed, so that we have automated. We told, okay, this mail we indexed as this type, and they manually checked and estimated, so said wrong, right. And it turned out that this 1.3% error rate, right? So really manually checked on thousands of elements. But when we compare our predictions with, so we have a dry run mode where we predict and we do everything, but we just don't write it to the database. And then we compare our prediction with what the user has done. And the error rate is bigger. So when we let them actually review our prediction, we bias them. Yeah. So I mean, it also says that maybe there are there are some freedom there. Yeah, some range of freedom, but so yes, but I would say, like, you know what? Actually, a very good idea. So I told you from the corporate point of view. Okay, this doesn't work now. From a corporate point of view, that when you want to introduce changes to a system in our environment, it's sometimes it seems like a small change, and then it ends up like a more complex thing. So this is the main reason why no, not yet, but maybe a good idea. So thank you for that hint. And for the first question, what do we have on our table? We actually, like Sebastian said, we applied the same pattern even in the next generation of it, on dispute capturing. So when invoices, when customers find something, need clarification on some invoice, they send us mail and say, hey, why should I pay that, or please explain. And this is something that is also coming in volumes and hard to capture, and has an impact on our cash flow if invoices are not paid. And this has been developed quite right after the indexing automation, and is running, not such high volumes, but this is the second pilot that is now globally rolled out. And this year we are looking forward for some similar use cases. So we try to apply the same success to other business areas that also receive a lot of mails, and then they have to distribute it. And so do this mail routing. Yes, this is what we basically do here. Yeah, but we have some like org matching, like getting an address and finding the organization within our system. And since the customer send us, for example, the address with typos, with variations, it can happen that you just either you create duplicates in your system, so add a new address, or so you already have it, or if you tried, for example, we use that for auto booking confirmation. So automatically, if someone books something, he has to give us information like an address where to pick up the container. And to automatically confirm the booking, we have to have everything in place. And if we cannot match the address to the organization, then manual handling is required. A human has to look in and do the matching. So this is one of the POCs Sebastian has analyzed, and so a lot of NLP ahead of us currently. But we also have use cases for image recognition, so damage recognition on container to generate repair work orders and so on. So Hapag-Lloyd is full of use cases and has a lot of labeled data.
So before we give room for the next question, let me just add some comment from the organization side. As you have noticed probably, is that time is flying, because our official end of this meetup is coming soon, but that does not necessarily have to stop us. So we can extend our meeting a little bit and just resume asking. So if you have to leave due to some time constraints, thank you for being here, but let's proceed in just asking a few other questions, because it was a very interesting and nice talk. Thanks, by the way. So who's next with a question?
Okay, since no one is asking, can I ask a question, a bit of a technical question in this regard?
Go ahead.
Hello, I'm Upayan. Thanks for the really nice talk. So I'm curious about one challenge that we experienced in an industry NLP project that I used to work on, is that when you have got this kind of varied data set with multiple labelings possible on them, as you said, that you already have an organization and labeling within yourself. But that also seems like quite a lot of manual work. So surely you are automating that process. And what we realized in our work, I do not know if you face this one, is that things like near tagging, etc., they did not work particularly well on an email kind of data set. Have you faced similar issues, of what should we think of applying if something like that happens?
So I think what you're talking about is the really usual problem of having a lot of data without labels, right? So
yes.
For example, in named entity recognition, usually people are just reading it and recognizing the entities and then taking actions based upon them, but not really labeling them anywhere. So in this scenario, you can, of course, use some sort of pre-trained model that already does named entity recognition, but these are, of course, really limited in the tags that they provide already, and you usually have a different use case. So in this particular scenario, I always recommend going with some sort of a mixed approach, like a learning system. So you have the humans that they usually do this task anyway. So you just introduce sort of a tracking system so that you track what they are actually doing. And then based upon this tracking, you train at some point, you will have then the labels, and then you can train. And then you have like some sort of an initial model, and then you could actually deploy that model and then make recommendations with it. And then the recommendations will be like more or less good. And then it will learn over time, get better with more labels and more interactions from the humans. But definitely this is a tricky one.
Yes, thank you for the detailed explanation. And just a comment. So we tried in our work a little bit of this one, though we had a limited amount of inputs in terms of entities, but at some point we realized that that a simple like pattern matcher or sequence matcher often works with these emails better than the named entity recognizers. We use spaces. So it is a question that has always bugged me, like how to do this one. Thank you.
Yeah. Sometimes the simple ones, like a simpler regular expression, is working much better than any fancy machine learning algorithm, right? So we also have always to keep in mind what is there already, what was used for years, and not just go with the latest and greatest, because it's not always the greatest. And it really depends on your data, especially neural nets depend on a lot of data to learn, probably.
Thank you.
Okay, I see 10 messages. Oh, wow. Okay, mostly thank yous.
So I have another question. So you said that one of the drawbacks from using BERT was the longer training times. So have you tried working with distilled models, which have a lot less parameters to train? So probably that would reduce training time while keeping a feasible result.
Yeah, that's a really good point, actually. Yeah, we haven't tried that. As I said, it was half a year ago, and back then this was really new with this distilled BERT and stuff. We wanted to have it as good as possible because we had a little bit of time for training, actually. But yeah, that's definitely a really good comment. So if you need quick results, then definitely try the smaller brother distilled BERT.
Any other questions left? I mean, it was a very good talk and answering a lot of questions already. So
that's good. So we were clear enough in our explanations.
I have one question, but it's related to the first talk.
Okay, I don't know if she's still here.
but probably we can say that is the part where the general discussion starts, which would, I mean, we can still go back to the second talk as well, but probably it's a good turning point for opening general discussion.
Maybe just ask the question because
I think you guys would know because you work in the domain.
Yeah.
So in the first talk she mentioned this transfer learning, and then there was one model which was trained with one language and then you fine-tune it with other language. What was it like that?
Yeah, I also think I remember that one. Yeah.
So is it like that some languages are easy to transfer to other languages because they share common roots, like languages that are based on Latin, and some languages you cannot do transfer learning because they have like a totally different structure.
So to that, I only know from some paper where Google did research with Chinese a lot, and actually this was one of the main reasons what you just mentioned, that why they introduced a special model sort of for Chinese really early, because these languages are quite different, and then of course the transfer learning will suffer from that quite heavily. Yes.
So
But
just to
yeah.
chime in there on that topic, because we've trained some, well, we fine-tuned on different languages with English as the origin, and we've actually, it's a Dilbert model fine-tuned on predicting sentiment, and we've noticed sort of cross-lingual language being created, where the model fine-tuned on just a couple of languages could handle Portuguese fine, for instance, after seeing a few Roman languages. When I say fine, I don't mean perfectly, but that's certainly an interesting topic, and there are some effects on getting some cross-linguality when fine-tuning to other languages.
Probably also depends on how many languages the original model was trained on, right?
Yeah, exactly.
Okay, guys, that was really nice experience. It's my first time that I joined this meetup, and both the talks were quite nice. And yeah, I hope you continue it. So is it like monthly meetup, or what's the frequency?
So it's actually 2 meetups that are taking place right at the time now, and probably it's the time. Camilla, are you there? Could you show the next slides? You're already doing that. So it's Hamburg NLP and PyData, and of course I think we will have a joint meetup as well in the future, but speaking for Hamburg NLP, it's just like we intend to do like 1 meetup every 2 months, and I think the same applies for PyData, but maybe one of them can jump in there.
For PyData, we do it every 2 months. And here on this slide, you can see the next dates as well. So for Hamburg and NLP, 23 of February, and for us, 24 of March.
Thank you. Then I wish
and
you
thanks
all...
for and thanks for your feedback. It was very kind. We are very happy that you enjoyed the meetups and the talks.
Oh, that's, yeah. Then I wish you all a very nice evening, and I'll leave. So have a nice evening.
You too.
It's also very nice to see that 34 persons are still in this meetup in the precious evening time. So thanks for the speakers. It wouldn't be possible without you and with your topics. It's really very interesting.
Happy to see that there is such a large and growing interest in data science and NLP. 4 years ago when I started, this was quite different, to be honest. There was like only one, I remember only one really meetup in this direction. And now there are a couple. So the community is growing also in Germany, which is really necessary, especially when we look into the next years. Without this technology, I think we will definitely lead behind in all industries. So yeah, cool to see all of you guys here. And also to you, thank you very much for making this happen. I know such stuff is also with a lot of organization overhead. So yeah, thank you guys for having us and doing all of this.
should we close, or anyone still would like to ask a question?
If there are more questions, you can also, of course, just message us on LinkedIn later, and then we can, from our side, we can also close it now. Then I think.
And everybody interested in NLP, please just join our Slack community, and you can start discussing there and getting information there. This QR code you see is all you need to enter.
Okay, so thanks everyone. Thanks to the speakers, everyone that joined us. Thanks to Hamburg NLP. It was great, and see you soon.
Thank you very much for having us. Great organization, great session.
Thank you. Have a nice evening.
Thanks, everyone.
Thanks, everyone.
Bye, guys.
Bye bye.